Welcome to another episode of Quality Quant Questions. Let's look at them now. The diameter of the rear wheel of a cart is 1.5 meters. In traveling a certain distance, the rear wheel makes 80 revolutions, while the front wheel makes 240 revolutions. Find the diameter of the front wheel. Okay. Now, the principal idea here has to be the distance traveled by the rear wheel has to be equal to the distance traveled by the front wheel. So, how much distance has the rear wheel traveled? It has a diameter of 1.5 meters. So its circumference should be diameter of the rear wheel into pi into the number of revolutions. This will be the total distance by the rear wheel. And this will be equal to 1.5 into pi, 125. A total of 125 because diameter of the rear wheel is 1.5 meters. Now, the same distance has to be traveled by the front wheel. So the front wheel will have diameter of the front wheel into pi into 240 has to be equal to 120 pi again. So this pi and this pi is cancelled, or diameter of the front wheel will turn out to be half or 0.5 meters, which is option C. Okay. Next question now. BOP are centers of semicircles AXC, AYB, and BZC respectively. AC is equal to 14. If AC is 14, then AB has to be 7 and BC has to be 7. Find the area of the shaded region. So area of the full semicircle AXC semicircle is going to be pi 7 square by 2. For the full AXC semicircle, this is going to be the area minus these two areas are going to be identical because the radius in both these cases is 3.5 and 3.5. So 2 times of pi 3.5 square by 2. So this and this gone. We are left with pi comes out. We are left with 49 square, 49 by 2 is 24.5 minus 12.25. So we get 49 by 2 minus 12.25. And thankfully, you'll see this will be equal to pi into 12.25 itself. The problem is the options are given in absolute numbers. There is no pi involved. So you have to get rid of that. So it will be 22 by 7 into 12.25. Will be 49 by 4. This is what we have to write. Okay, so cancel 7, cancel 2, sorry, 11. Our final answer has to be 77 by 2, which is equal to 38.5, or the correct answer is option D. Okay. Next, chords PQ and XY intersect at right angles. Find measure of QPX, this angle, and measure of PQY, this angle. Okay. Let's say there is a center of the circle somewhere here. Now, if I were to join the centers to these 4 points, this 90 degree is the angle between the chords. So, how is this generated? If this is 2x, this is 2y. If this is 2x and this is 2y, we know 2x plus 2y, half of this, half of 2x plus 2y is the angle between the chords. This is given to us equal to 90 degree, or X plus Y is equal to 90 degree. Now, and another wonderful thing, look at P, let the center be. POY will be twice of PQY. So this is 2Y, this has to be Y. Similarly, QOX has to be twice of QPX. QOX has to be twice of QPX. So this angle here has to be X. So when the question asks me measure of angle QPX, which is X, and measure of PQY, which is Y, they're asking for X plus Y. And we already know X plus Y is 90. So the correct answer to this question is option B. Next is the length of the chord is root 3 times the length of the radius of the circle. Then what will be the angle inscribed in the arc AB? Okay. This is a let's say this chord is here. This is very, very basic knowledge. If this is R, this is R, and this is root 3R. This is root 3R. If you are familiar with the 30, 30, 120 triangle, the ratio of sides there is 1 is to 1 is to root 3. And therefore, you can directly jump to the conclusion this has to be 120 degree. These two have to be 30 degree and 30 degree. You can directly jump to that conclusion. If you are unfamiliar, perhaps what you can go down is, let's say from here, I draw a perpendicular. Because it is a chord, the perpendicular will bisect the chord. So if this is R, this is R, this full length is root 3R. This will be root 3R by 2. This will be root 3R by 2. And then perhaps the 30, 60, 90 triangle will come to your head because look at these two sides. They are in the ratio root 3 is to 2. So this length here must be R by 2. R by 2, root 3 by 2R and R, the 30, 60, 90. So here it has to be 30 degree. Here it has to be 30 degree. Here it is 90 degree. So this angle will now be 60 degree. This angle will now be 60 degree. And now we can say the angle inscribed. The angle inscribed will necessarily be 120 degree. Either way, you can use, but you will definitely get to the answer. The angle inscribed is indeed 90 degree. Okay. Next question. A wire of length L can form a circle of area 154 centimeters square. Okay. If a circle has this area, so pi r square, 22 by 7 r square is equal to 154. Cancel 7. The radius of the such circle is going to be 7. Now, remember, because you're using a wire, essentially what is being talked of is the circumference. So length of the wire will turn out to be L will be equal to 2 into 22 by 7 into 7. Or length of the wire will be 44. Length of the wire will be 44. If a certain end portion of the wire is cut, it forms a circle of area 38.5 centimeters square. See, the area has become 1/4. The area has become 1/4. That should directly give you the indication. The circumference should become half. If area has become 1/4, it is in the ratio 1:4. The length should be in the ratio 1:2. Find the length of the portion of the wire which was cut. If you can get to 1:4, you can directly come to half. Otherwise, we can do the same processing again. 22 by 7. This time, let the radius of the new circle formed be B. B square is equal to 38.5. So I can cancel off 11. or I can write it as 7 by 2, or B will turn out to be 7 by 2 itself. The new radius, the new circle that is formed. Previously, it had a radius of 7. Now it has a radius of 7 by 2. So what will be the length here? It will be 2 into 22 by 7 into 7 by 2. Or the new length of wire that is used. New length of the wire that is used is 22. Originally, the length of the wire was 44. Now, only 22 are being used. So, what portion was cut off? It is 44 minus 22. The answer to the question is, of course, option C. Next question now. In the adjacent figure, PQ is a chord of a semicircle with diameter ST. ST is 9. PS is equal to QT is equal to 3. Find PQ. Okay. So PS is 3. QT is 3. I'm dropping perpendicular on either side. Now, if this, okay, this is the center. ST was 9. If this is 8, this is 4.5 minus 8. This length here is 4.5 minus 8. Okay, nice. If this is H, this length here will be 4.5 only. This is the radius from the center to P. From the center O to P, the length will be 4.5 only. And a similar thing would happen on the right hand side also. This will be 4.5. This will be 4.5 minus 8. This will be 8. This will be H. So I have A square plus H square is equal to 9 for triangle PSM. For triangle PSM, A square plus H square is equal to 3 square. And for triangle PMO, we also have 4.5 minus 8 whole square plus H square is equal to 4.5 whole square, which is 20.25. So I need A. I need a value of A. So second equation minus first equation, if I do, I'll get 4.5 minus A into 4.5. H will get cancelled out entirely. This will get me to 11.25. Okay. So let us divide it by how much? 9. This will become 0.5. This will become 1.25. I'm guessing 22 to 45. Okay. Or 4.5 minus 2A will be equal to 2.5, or 2A is equal to 2, or A is equal to 1. Now see, if SM is equal to 1 and this A is also equal to 1, MN, let me call this, MN will be equal to 9 minus 2, 7, which should also be equal to the length of PQ. The length of PQ will therefore turn out to be 7, which will be the answer to this question. Next, two circles with diameter 16 and 12 touch each other internally. Find the distance between their centers. Okay. Let's say one circle is this and the other circle is this. They are touching each other internally at this point. Now, you simply have to ensure that you are making the diameter passing through the centers of both these circles. Center of the larger circle will be somewhere here. Center of the smaller circle will be somewhere here. Now we are told this has diameter of the smaller circle is 6. So this is 6. Or radius of the smaller circle is 6. And radius of the larger circle is 8. Because the diameter is 16, radius of the larger circle is 8. So the distance between their two centers will definitely be 2. Will definitely be 2. And that is the answer. Okay. Next question. If P is the center of the circle and angle ACB is 65 degree, find the measure of arc AXB. This is essentially, remember, they are asking for this angle. Okay. We can happily see that because this is a tangent, this will be 90 degree, this will be 90 degree, and this is a quadrilateral. APBC is a quadrilateral. So all of the angles should add up to give us 360 degree. These two add up to 180. This 65. So this angle here has to be 115 degree. Or option B is the answer. Okay. Next, in the given figure, angle EDC is 54 degree. And DCA is 40 degree. DCA is 40 degree. Find X, Y, and Z. Now see, according to tangent secant theorem, if this angle here is 40 degree, this will be the same angle that chord DC subtends on the circumference of the circle. So if this is 40, X is also 40. By the same metric, EDC, this 54 degree should correspond with this Y. Should correspond with this Y because ECB is the angle between the tangent and the C. Tangent and the chord C, and this chord will therefore subtend 54 degree of the circumference. So Y is equal to 54 degree. And then you can see 40 plus 54 adds up to 94. Z has to be the supplementary angle. It will be 86 degree. Or the correct choice here has to be option B. Okay. Next question now. For the figure shown below, blah, 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 blah. OPOQ is equal to OAOB is equal to 15. Which of the following relations is true? Okay. See, a lot of the questions included here are mostly basic definitional diagram building questions. Hopefully, the diagram building part of it comes through. Let's see. Capital R. So larger radius is 9, smaller radius is 2. Which of the following relations is true? Now we can, if you don't know what direct common tangent is and transverse common tangent is, perhaps you should read up on it. Otherwise, those of us who are familiar with those basic terms, we can directly come to see PQ, length of the direct common tangent. PQ should be equal to under root of distance between the centers whole square minus the difference of radii square. So 9 minus 2 whole square, which should give us 225 minus 49, which should give us under root 176. Now this is 13 point something something. This is 13 point something something. Okay. Now, the cross tangent or transverse tangent AD equal to under root 15 square minus sum of radii whole square. So 9 plus 2 whole square or 15 square minus, 225 minus 121, which should be under root of 104, which will be equal to 10.xx. Now, the fact that PQ is greater than AD is undisputed. This is definitely true. But beyond this, we would have to be a little more certain. whether PQ is equal to 13.3 and 10.2 and all of these. If you go ahead, you would see PQ is not exactly equal to 13.3. AD is not equal to exactly 10.2 because 10.2 whole square is equal to 104.04. But roughly, both these things are equal. And therefore, the correct answer to this should be all of these. Which of all of these relations are necessarily true? Okay, next question. A, B, C, D are wheels of equal diameter. A and B are tied with a rope as in figure 1, the way it is shown. C and D are also tied in figure 2. AB is equal to CD is equal to 2 times the diameter of the wheels. So if this is R, this is R, this length here is 2R. Okay. Distance between the centers is 4R. That is known to us. AB is equal to CD is equal to 2 times the diameter of the wheels. Two ants are moving on a marked path as in figure 1 and 2. Okay. So the marked path is the portion that is continuous. This broken down portion is not where the ant travels. The portion that is continuous is where the ant is traveling. Find the ratio of the distance covered by the ants in one round. That is ants traveling in the paths figure 1 and figure 2. Okay. First thing you need to see the path traversed by the ant here is going to be one direct common tangent, one more direct common tangent, and then half the circumference, then another half of the circumference. This is the path taken by the ant here. So I'm going to break it down as the full circumference, and do direct common tangents. Full circumference is going to be how much? Full circumference is going to be 2 pi r plus direct common tangent here. Now this direct common tangent is very simple to do because the radii of both these circles is identical. Can I say the direct common tangent is as good as 4r? And another 4r. So altogether we are getting 2 pi r plus 8r. For the first one, we are getting 2 pi r plus 8r. Okay. For the first ant, this is the distance being traveled. Let us go to the second ant. What would happen here? Okay. Again, one half of the circumference. Sorry. Yeah. And another half of the circumference. And then the transverse tangent. Then the transverse tangent. Again, this time, if we have to break it down, circumference size, we will definitely get 2 pi r. We will definitely get 2 pi r. The only thing that will change this time, is look at this transverse common tangent. It will now turn out to be plus under root of 16r square minus 4r square. R plus r whole square will be 2r whole square or 4r square or 2 pi r plus r root 12. These are the two distances being traveled. We now need ratio of them. First thing I can get rid of is r everywhere. So I will have 2 pi plus 8 by 2 pi plus 12 under root 12. Okay. Now pi, we were told in the question to be taken as 3.14. So 6.28 plus 18 is 14.28. Now under root 12, I will take it under root 12, I can take it as, wait, 2 pi, so 6.28 plus 2 root 3. Wonderful, I can get rid of 2 everywhere. It will be 3.14. This will be 7.14. So under root 3, I can take as 1.73. 3.14, 1.73. So 7, 8, and how much? 4. Oh, oh, I have made a mistake. I have made a mistake. Because, see, this cross tangent, transverse tangent, it has to be included twice, no? It has to be 2r root 2. So this into 2. So this into 2. So I need to add 1.73 one more time. So 0, 6, 6. Okay. So the final ratio that I'm getting will be 7.14 by 6.6. This ratio, we have to ascertain whether it is less than 0.5, between 0.5 and 1, between 1 and 1.5, or greater than 1.5. It is not greater than 1.5. Greater than 1.5 would lead it to 9.9 by 6.6. It is definitely greater than 1 because the numerator is greater than the denominator. So option C should be the answer. These two will get rolled out. And that's it. Both these questions are mainly about direct common tangent, but direct common tangent doesn't get tested here. It is more transverse common tangent that gets tested. Okay. Next question now. Find the approximate area of the shaded region if the two circles are identical. The two larger circles are identical, and O1, O2 is equal to 3. So the radius of the larger circles is 3. O1 and O2 are centers of the circle. O1, O2 is the diameter of the circle in the common area of the intersection of circles having centers O1 and O2. Okay, let's work it. First need this. I am drawing a line here. I'm drawing a line here to this point and to this point. Hopefully you can understand. Next, I'm also drawing a line here. Hopefully you can see it is a rhombus getting created, and the fact that one of the diagonals of the rhombus is equal to the sides of the rhombus. It means it is a 60-120 rhombus, which means this angle here has to be 120 degree. This angle here is also 120 degree. These two angles here are 60 and 60. I need to use a different colored pen for this portion. This here is 60 degree. This here is 60 degree. But these two angles here have to be 120 degree each. Have to be 120 degree each. With that in mind, can you see how this has to be calculated? First, I will calculate this segment. How will I do that? From this sector that is subtending 120 degree at the center, I will remove this triangle's area and I will get the area of this segment, to which I will add the area of this segment again. So now the common portion, this shape that I have here, that area will be known to me. And then from that, I will remove the area of the circle. Okay. Prior to doing any processing, you should ideally have the storyline set up. Okay. So I know radius is 3. So area of the sector will be 1 by 3, because 120 degrees or 120 by 360 by r square. R square is 9 minus the area here will be half into 3 into 3 into sine 120. Okay. So this gives me 3 pi minus 1 by 2 sine 60 is root 3 by 2. No, sine 60 is root 3 by 2. So 3, 9 into root 3 by 2, or we get a total of 12 pi minus 9 root 3 by 4. This is one sector. Let's get the other sector involved also. That will make it 2 times. And from this, let me remove the area of the circle. Area of the circle will now turn out to be area of the circle. Okay. The radius of the circle is 1.4 or 1.5. So area will be pi times of 2.25. Cancel, cancel. 2. I am getting 6 pi minus 4.53 minus 2.25 pi. 600 minus 2.25 is 3.75. So I'm getting 3.75 pi minus 4.5 root 3. This is the final measure, precise measure that we are getting is this. But I can't be working with this because finally what I need is one of the numbers given here. So I'd have to start writing stuff down properly. 3.75 I'd write as 15 by 4 into 3.14 minus 9 by 2 into 1.73. Okay. Then maths will be needed. I'm saddened. 1.57 by 2. This will roughly turn out to be how much? I'm using the calculator. I'm not too interested in doing this in my head. 15 into 1.57 divided by 2 is equal to 11.775. 11.775 minus, I have 9 into 1.73 divided by 2 is equal to 7.785. Okay. So difference between them, if I'm seeking 5 minus 5 is 0, 7 minus 8 will be 9, 6 minus 7 will be 9, 10 minus 7 will be 3. I'm getting 3.990. I'm getting my answer is 3.990. Or among the available options, the one that I will mark is option C, 4 centimeters square. But hopefully, see, the maths of it is aside. The processing of identify, we have to get one segment, then another segment from which we have to remove the area of the circle. That is something we understand. Okay. 4 50 paise coins are arranged in such a way that each coin touches two others and centers of the coins when joined form a square. What is the area of the square so formed that is not covered by the coins? The maximum distance between any two centers is 392 under root 392. Okay. Under root 392 is 14 root 2. So essentially what is being talked of is, see, you have a square in which you have one point placed here, another coin placed here, another coin placed here, and another coin placed here. Forgive my diagramming skills, they are not very accurate, but hopefully you can see. You are told the maximum distance between any two centers is of course going to be the diagonal. This 14 root 2, which means side of the square is of course 14, which means radius of the coin is 7. Radius of the coin is 7. So essentially what is being asked of you is find the area of the square, which is 14 square, minus 4 quarters of a circle or one full circle. One full circle. So pi 7 square. This is what you are expected to calculate. So 196 minus 22 by 7 into 7 square. 22 into 7 is 154. 196 minus 154, or the answer in this instance is going to be 42 centimeters square. Okay. Next, a square gymnasium has a rectangular swimming pool of area 154 square units at its center. Okay. A, B, C, D are corners, R and B 4 entrances to the gym. The shortest distance from any of the 4 entrances to the swimming pool is 10 root 2 minus 7. Okay. What is being talked of here is length from here to here is 10 root 2 minus 7. Okay. And given that area is 154 square units, can I also say the radius of the circle is 7? Or this line here is 10 root 2. Now diagonals of a square are bisected, are perpendicularly bisected by each other. So if this is 10 root 2, this is also 10 root 2, or the diagonal of the square, is 20 root 2. Or side of the square is 20. Side of the square is 20. So what the question is asking of us, again, find the area of the gymnasium not covered by the swimming pool. It is simply going to be 20 square minus 22 by 7 into 7 square. Area of the square minus area of the circle. We get 400 minus 154. Or the final answer is 246. Option C should be the answer here. Next, in the figure, square ABCD is divided into 5 equal parts, all having the same area. T is the central part. T is central part. T, the central part, is circular, and lines A, B, F, C, G, D, H lie along the diagonals of AC and BD of the square. If AB is equal to 11, find the radius of the circle of the central part. Now, this has a lot of extra information to distract you, but if you pay attention to the relevant details, life will be simple. See, this is 11. So can I get the area of the square? It will be 121. 11 square. Now, area of all the 5 parts is identical. So area of the circle is 121 by 5. 121 by 5. Now, we are finally asked radius of the circle. We know the area. So it should be pi r square is equal to 121 by 5. Or r square should be equal to 121 by 5 pi. Or r should be equal to 11 by under root 5 pi. 11 by under root 5 pi. Or option A is the answer. This is it. This is all that the question demanded of us. Now trying to figure out what is the length of AE and everything else is going to be an unnecessary burden that is not needed. Okay. Next. If a circle is inscribed in a quadrilateral, then which of the following is true? That's one. See. Circle some quadrilateral So now, see, from this external point, the tangential length here is x. From this external point, the tangential length is y. The length of tangent from an external point to the circle is always going to be identical. From this point, it is z, and from this point, it is w and w. Let's say this is a, b, c, d. Look at the first option itself, AD. AD is x plus y. BC is w plus z. And AB is x plus w. And CD is y plus z. Can you see? Left side is x plus y plus w plus z. Right side is x plus y plus w plus z. So yes, this is most definitely true. This is most definitely true. Now, you can go ahead and ignore everything else. AC is equal to BD, not necessary. AD plus AB. 2x plus y plus w has to be equal to 2z plus y plus w, or 2x has to be equal to 2z, not necessary. Angle D plus angle B has to be equal to 180 degree, not necessary. You can generalize this. While this question is only talking of a quadrilateral, you can generalize this with for any even sided polygon that inscribes a circle, sum of lengths of alternate sides is equal. Basically, if it is a hexagon, side 1, side 3, side 5 will add up to side 2, side 4, side 6. But then understand it has to inscribe a circle, not that just a circle has been fit inside the figure. It has to inscribe a circle. Inscribing it would mean that the circle is touching all those sides. The circle is touching all those sides that are present in the polygon. Okay. Next idea. 4 dogs are tied with chains of equal lengths, such that the points where they are tied, when joined, form a square whose side is twice the length of a chain. If the length of the chain is b units, what is the area enclosed within the square which cannot be accessed by any dog? Okay, this is very similar. It's very similar to what we have done earlier. Let's see. One dog is here. The area he can access is going to be a quarter circle. Another dog is at the right top corner. The area that he can access is going to be a quarter circle. The area this fellow can access is a quarter circle. The area this fellow can access is a quarter circle. So, if the length of chain of a dog was b, the length of the side of the square is going to be 2b. So the area which cannot be accessed by the dogs, this area in between is going to be 4b square minus area of the circles. 4 quarter circles add up to a full circle, minus pi b square. If I take out the b square common, I'll be left with 4 minus pi, which is given to us in option 1. This has to be the answer. Okay. Next. An ant is standing at the center O of the circle shown here. It needs to reach point C, which is exactly midway between A and B. Okay. The ant can move only along the circumference of the circle and radii OA and OB. What is the ratio of the shortest distance to the longest distance that the ant can travel in order to reach the point C from point O if it is known that it doesn't travel along any stretch twice? Okay. Now, if the ant has to come to C, the shortest distance that it can travel is going to be along one of these diagonals and then this path. So, if this is precisely in between A and B, this angle here should be 60. So, this length here is 1/6 of the circumference plus radius. So, radius plus 1/6 of circumference. 1/6 times of 2 pi r. This is the shortest distance. Now, if the ant was being crazy and it wanted to travel the longest distance, then how the ant would do is this. It will come here, then take the longer path along this edge, then come all the way here, which is again the radius plus 5/6 of the circumference. Radius plus 5/6 times of 2 pi r. So we need the ratio of these two. Let us work. I'll have 1 plus 1/6. So let me make it 6 plus 2 pi by 6 plus 5 pi. No, 10 pi. R and R cancelled and 6 multiplied here. So that it gets cancelled. So now it will be 3 plus pi by 3 plus 5 pi. 3 plus 22/7 and 3 plus 110/7. So 7 into 3, 21, 43 and 131, which is indeed option D. This should be the ratio of the length traveled for the shortest path and the longest path. Okay. Next question now. A circle has a chord of length 20 centimeters that subtends an angle of 60 degrees at the center of the circle. Okay. If this is 20 and it is subtending an angle of 60 degrees at the center, it means, see, this is radius, they will be identical. So this is 60 degree. This is also 60 degree. So the length of radius of the circle is also 60 degree. Find the approximate area. Achha. Another circle is drawn with chord as the diameter. Okay. Just know this much that the radius of this circle here the radius of this large circle is 20. Another circle is drawn with this as the diameter. Trying to make the diagram very nicely. This is it. This is it. Okay. Find now. We are looking for Find the approximate area in centimeter of the common region to both the circles. So we need this area. We need this area. Okay. Now, see, let's say the center of the circle, larger circle was here. This length here and this length here. Hopefully, you can break down the shape into this portion. This is segment of the large circle. This is segment of the large circle, which perhaps you can get. And then the other area is half the area of the small circle. So segment of the large circle is our challenge. Let's work out. We know radius of the large circle is 20. So, and this was subtending an angle of 60 degree. So this full sector will have an area of 1 by 6 pi r square, pi r square, which is 400, minus area of this triangle will be root 3 by 4, 20 square, equilateral triangle, side 20. So 400. So this will become 200 pi. I will also keep 200 here. So 200 pi minus root 3 by 2. This will be the area of the sector. Given that they have told me to take values like these, I'll go ahead and replace it directly. 200 into 22 by 7 minus 1.73 by 2. I'm again using the calculator. I'm not too fussed about getting it accurate. So 2, first I have to do the intercompartment. 22 divided by 7 minus 1.73 divided by, oopsie, I can't do that. First thing is 1.73 divided by 2. 0.865. 22 divided by 7 is equal to this minus 0.865. So I'm getting 200 into 2.2778, something like this. So I'll make this 2.278 or 2.28. Directly 2.28. 200 into 2.28. So that I get 228 into 2 or 456. But then this is insane. How am I getting this much? Because if my options are only this much and I'm already getting 456, I'm already getting 456. My maths has to be off somewhere. Let me check again. .14 minus 0.865 is this into 200 is equal to 455. Am I doing something off? 1/6 of the larger circle, 1 by 6 of pi r square minus root 3 by 4, root 3 by 4, root 3 by 4 into a square, 20 square. Okay. How is the area, only the sectoral area turning out to be so large? Must have done some mistake. Let me start my thinking and writing all over again. Circle has a chord of length 20 centimeters, obtains an angle of 60 degrees at the center of the circle. Another circle is drawn with the chord as the diameter. Don't care. This one right now. I'm more interested in 1/6. Okay. I now know what is the problem. Last time I done 406, cancelled, made it 200 pi. 200 pi by 3 should have been the number. That is my error. Minus root 3 by 4 into 400. So I can break it down this way. 400 I've taken out common. I'm left with 22 by 7 into 6. So 22 by 42 minus root 3 by 4. So 400 into, how much is this? 11 by 21 minus root 3 by 4. So this is roughly 50%. This is roughly 50%. And this is 50%, 52%. 52% minus 1.73 or 0.52 minus 1.73 by 4. Let me put it down this way. 100 हो गया, 4 से काटा तो कितना बनेगा ये? 4 1 3 2. So we get minus 0.42, or I'm getting 400 into 0.1, which is giving me roughly an area of 40. Yes, this is much more appreciable. This here gives me an area of roughly 40. This gives me roughly an area of 40. Now, half the area of the larger circle, that will be pi 100 by 2, or 22 by 7 into 50. So this is roughly 150-ish. Is roughly 150-ish. 3 into 50. I'm getting a 40 from here. I'm getting a 150 from here. 150 plus 40. Among the available options, the only one that I can mark is option C, and that should be it. Unnecessary calculation took up a lot of time. Otherwise, the question is fairly straightforward in terms of what needs to be done. Okay, next question, and the last question. In the given figure, BC is the diameter of the circle with center O. Okay, if BC is the diameter, first thing we know is this is 90 degree. AB and AC are two equal chords. Great. If AB and AC are two equal chords, this will be 45 degree. This will be 45 degree. Wonderful. Also, POQ is equal to 90 degree. POQ. This is also 90 degree. If the area of triangle ABC is 50 square units. 50 square units. Find the area of POQ. Area of triangle ABC is 50 square units. Okay. If length of AB is X, length of AC is also X, length of AC is also X, length of BC will be root 2x. Now we know half of x square is equal to 50, or x square is equal to 100, or x is equal to 10. AB and AC are equal to 10. So BC, or the diameter, is equal to 10 root 2. So radius is equal to 5 root 2. Remember, OP and OQ are radius only. OP and OQ are radius only. So, if I'm looking for area of TOQ, it will be half into 5 root 2 into 5 root 2. Cancelled everything, we get to 25. Or the answer to the question has to be 25 square units. And that is the entirety of this sheet. Hopefully you learned something.